perceived performances is expectation, real performances, and something in the middle. How do we perform? How do we do during the transition? So performances is something which is really measurable. Expectation is something that comes from your deep in. Okay, what's in the middle? So today we talk about perceived performances. Okay, and then I've been in that situation quite a lot of time. We go through a definition, we already been, so we go through really quick. We go through understanding what is to wait for and why nobody wants to wait for. Okay, then we have a bit of demo, and in the end I will disclose with you how we can use perceived performances, knowledge, and tricks to have an easier life at the office, to fool your own boss. So perceived performances is a function which has performances, expectation, and UX applied to computers, applied to front end, what we do. Okay. Normally, it applies like 80% of the time. It applies to loading time, and it is the argument of tonight. We will look some scenarios around the links. No more. It's really well scoped. So when it comes to links, we have some expectation when we are like with the mouse just about to click on a link. The expectation is, first, I will see some awesome content. Second, I will have that content straight away after the click. Then there is the performance. Okay, content normally sucks a lot after you click it, and after you click it, you wait. Okay, that's something that happens for every website. You can do a lot of optimization, but there is a waiting time. Then UX is just stick in the middle. It's stick in the middle and can help to move and to smooth this transition, this waiting time. It can reduce the distance from performances that can really, really be bad and the expectation that are normally really high. And then we come to waiting time, because when it comes to link, we click and we wait. We click and we wait. What is waiting time? Waiting for human beings is when you just stand still, you have nothing to do, and your mind just goes crazy. You really hate that because you are not busy. Okay? Human brain has two main states, which is an active state and a passive state. When you are in an active state, like drinking a beer, having a conversation, going to work, you have a really, really fast perception of time passing by. Time goes faster. When you are passive, when you have nothing to do, when you are bored, time never goes by. Okay, I think everybody experienced that every Sunday. Okay, that's the day after. So let's see how this works in some demos. Okay, we said that links are the foundation of the web. So the web, for everybody who doesn't know that, is a composition of resources which are linked through connections. Connections that eventually works like that. I click on a region of my page and something is loaded. Okay, that's a classic link that we find. This link is running on my machine, is working on my machine actually, so there is basically no latency. The moment I click the link, I have the response straight away. There's no latency. But this is not really happening in the real world. In the real world, we have some latency. So I click something, I just clicked and nothing happened. There is an indicator up there in the tab, and okay, eventually something will load, hopefully. Situation may change a bit. I don't know, there is a random waiting time here, so it can be faster, it can be slower, but still you have to wait. If you surf the web with your phone, you will experience all these waiting times. What do we do? How can we just move on and reduce this problem? Well, we can use a technical implementation, a technical solution to improve the performances, the measurable performances of the waiting time. So like almost 10 years ago, there was a discovery that was AJAX, Basically, somebody in IE, if I'm not totally wrong, forget to close a socket connection, and that made possible for a JavaScript code to access the connection that was already established with the server and wrote new requests with that server. Basically, you skip the handshaking, you skip the initial ping pong of information that your browser deal with the server. That makes a link extremely, that makes a request faster than a normal HTTP link. Okay, it works more or less like that. You click a link, a request is made through this channel that is totally transparent to you. Something come back and you modify on the fly the page to insert the new content. Okay, so that's what happened. I click something and the new content comes here. There are a lot of implications around that, but what I'm interested here is that it's normally way more faster than the same link running through HTTP. Okay, problem is AJAX doesn't give any feedback. So if I click, I don't know what's going on completely. It can be fast, but I don't know what's going on. If we go back with the link implementation, at least I have the little spinner in the tab. It's not much, but it's something I know that I'm waiting for. So then, keeping with technical implementation, we developers that are quite smart, we implemented a solution. So we give feedback to the user through a loading spinner, amazing loading spinner. I refuse to use the loading GIF here, so we're using CSS to make something more cool. Okay. So loading spinner is no more than a mean to give a feedback to the user that state out loud, come on, you are waiting, you are in passive mode. If it's fast, it's good. If it's not fast, it's really, really bad. So how can we improve the user experience? How can we, given that the loading time doesn't change because you are on 3G, the server is pretty weak because your boss doesn't want to pay a lot for that server. There can be a lot of motivation. I can tell you some war stories about bosses who don't want to pay for a decent web server. Well, we can keep the user mind even more busy. So instead of serving a simple spinner animation, we can try to serve a more complex image that will capture the user attention for more time. Because if I show you an animation, something really complex, your mind will be tricked in the active mode. It's not passive, it's active. Now suddenly you are not waiting, you are trying to understand what's going on in the picture. Okay, I like clouds, so I work with iCloud, so that's really cool because you can't detect when a frame ends and the next start. You can watch that GIF forever, more or less. But we can do more. We can do more. What if the loading time is extremely busy, is extremely slow? I book flight planes quite a lot because I'm Italian. I have to fly back there to pay taxes, more or less. Okay, and it's really awful when you search for a flight. You like fill your data. I want to fly. Okay, from Malmö to Italy back. You click search and nothing happened for 30 seconds. I hate it. The feedback I have is like, we are finding the flights for you. Okay, I know that already. I asked for it. You don't have to tell it. That's crazy. So this is a bit of a provocation, but what if during the waiting time the user can play? Okay, so now I can't stop playing. It's really, I mean, you can come here. It's beautiful. Okay. And when the page is ready, instead of break my gaming experience, I just have a notification. Okay, guy, man, your content is ready. You can keep playing because it's so cool. I mean, it's like, that's Canvas. That's the future. Okay, but if I want to see my content, I can click OK. Overlay goes away, and I finally have my content. This is just another example, a bit far too complicated, to keep the user mind busy instead of having an angry user waiting for your content to come. Is that all? No, we have a lot of stuff more. But now we just saw how we can face a slow loading time and smooth the user experience. So we actually, the gaming experience was 3 times slower rather the GIF experience, and the GIF experience was 2 times slower rather the simple loading experience. So during those demos, I progressively augmented the waiting time to 7 seconds for the game. Okay. The point is that the more active is your mind, the less you perceive this waiting time. And a lot of effort that we put when it comes to perceived performances is to just try to take the user attention away from the waiting time. So we don't really have to optimize on the backend. But say we work with really, really clever guys in the backend, and they over-optimize our website. So they do a job that is just a little bit too good. Let's try that together. So let's keep 2.5 seconds. I have here a waiting time of 1.5 seconds. That's acceptable. Then my backend goes further and reduce the time to 0.8 seconds. It starts to be annoying. So the loading curtain, this grayish with animation thing that appear in the screen to give me feedback, it goes away really, really fast. Let's keep 0.5. Today, 0.25 seconds for loading a JSON cached API is not that much. It's just a bit, it's almost the double of a normal, what's the name? DNS delay time, I missed the term. Yeah, the latency, thank you. So it's just about the double. So you pass through the latency and you have the data. That's quite normal. What happens if I load a link like that? Okay, it's just flashing. Why is this bad? This is bad because a user that doesn't know how the website was made, he doesn't have the time to understand what's going on. And this is another really important part of perceived performances. It's the expectation. An expectation that I told you before about links is that a link should be fast. And we already saw how to trick you to think it was fast. Another expectation that you have about yourself, that I have about myself, is that I am quite smart. I don't think I'm stupid. Okay, so everything that happens before me, I would like to understand what's going on. I don't like to do not understand. If I don't have the time to understand what's going on a page, I will have a really, really bad reaction. And because I have the expectation to be smart, I will just point the finger on your page and I say, okay, this website works like crap. Okay, it can be fast, but I think it just works like crap because I don't have the time to understand. So a really quick loading time can be extremely bad for the user experience. Let's step a bit into code here, which was 8. So far, we use an extremely simple jQuery code to implement our AJAX loading script. Are you comfortable with JavaScript? Yes, good. So what do? We fetch a click, we prevent the default even, we show the curtain, we route the AJAX request, and when the response comes, we just change the content and we hide the curtain. That's the simplest possible code that you can implement in a website to have this AJAX feature working. I mean, I did that since 2005 in literally hundreds of websites, no more than that, nothing really difficult. And in the beginning, it was working fine because I stepped from like 2-3 seconds of page loading time to 2 seconds, and that was good. But today it's not good anymore because something can be really, really fast. What we can do? We can buy time. That's the first simple solution. So even if we have 0.5 seconds, we can just say, okay, when the page is ready, wait 1 second more. Let's tap into the code. This is really, really simple, I tell you. We just time out the disappearing of the curtain. So it's okay, my content was there, it was fast, but just wait a bit more so the user have the time to understand what's going on. This is extremely cool because it's 2 lines of code, no more than that. It works perfect for fast load time, but it works really, really bad for slow loading time because you just add 1 second to an already painful 2.5 seconds of waiting time. So you get 3.5, that's unacceptable today. So what can we do more? If we can't buy time, we can try to sell time. So as a developer, I'm a greedy person. I want money. So what if, even for the fastest possible loading time, I just slow things down and ask you to buy me a beer? Okay, and I can put an advertisement. It was too fast. I can put an advertisement pointing to a PayPal page in which you can just give me a beer, for real. Please go there, do that. Okay, so that's another provocation that I put tonight. But it's just a way, a creative way that we can use to exploit this moment in which the user is busy. So if it's waiting passively for too much time is bad. If the thing is too fast is bad. What do? We put advertisement there. Simple. This solution is technically the very same of the other. So there is a timeout which is simply way bigger because we want the advertisement to be extremely visible. And yeah, I put a link with an image into my cart, and it cannot be simpler than that. And it may work. It may work. But we can go back to a technical implementation and try to find some fine-tuned solution with our code to solve this problem. Well, one solution is to keep a bit of buying time thing, but to apply a transition, to apply an animation to the curtain. So during whatever animation, every time something moves before your eyes follow the movement. Okay, if something is fading, okay, I stay here because then you look the GIF, you don't look at me. If something is moving, your eyes are just captured there. You don't do anything else but looking at this. So if we add an animation before and after the usage of the curtain, we buy 0.4 seconds before and 0.0 seconds in the end that your brain just don't perceive as a loading time. Okay, so even if we add time to time because of the simple solution, we can add a quite simple CSS solution to smooth down the side effect of the buying time for the user. Yeah, here I want to give you something. Because I've used the jQuery, I want to be really, really precise on that. You can be tempted to just use fade in, fade out that jQuery still implement in JavaScript. Don't do that because it's really, really flashy. That just doesn't work good. Please go with CSS transitions because it's really important for the human eye the smoothness of the animation performance. So you may think, okay, I'm putting here an animation so the user is really, really happy, but then the animation go like this, and you get a really angry user. Okay, you need to get to 60 frames per second to have a good user experience, an experience of proper movement. With this, for this example, the fading, I can't. We can try it later. If I switch back to the fade in, fade out that I did in the first time because it's unfairly easy, you can't have a good user experience. It just doesn't work well. So keep in mind to exploit CSS to do animations because it just works fine. Let's go to the real thing, how to solve this problem for forever. A bit more JavaScript, of course. Instead, so we have fast loading time and slow loading time. and we want to solve both the problem. The problem after these two problems is that we don't know before how long the time of the waiting it will be. We don't know when we click the link how long it will take to load the link. Okay, it can be fast, it can be slow, we can't predict that. So we have to do something clever here. The simplest possible solution that I imagine is we have this loading curtain, it's working good with the animation, we are really happy. We just wait a bit before to show it. So we say, let's wait 0.8 seconds. If the page, if the content loads before, we don't need the curtain. If the content takes more than 0.8 seconds, we think that is a really, really slow loading time, and we show the curtain. Let's try that. So I have an extremely fast loading time. Good. Check now is approved right away. It's immediate. You don't have, you don't even notice that something is going on. 0.5, it's almost the same. 0.8, that's, for me, I don't know for you, but for me it's already, I have the time to understand that I clicked and what? Luckily, just in the moment I started to ask something to myself, the contents arrive. So it's kind of cool. 1.5, okay, I have the loading time, but you saw the curtain stays so short time that in the end you maybe think that it was fast, even if it was pretty slow. And okay, you get the 2.5 is almost the same thing. So let's go to the code here. That is actually the interesting part. What we do to achieve this, this result is to detach the loading part and the loading code where you really do the fetching of the data from the showing the curtain thing. So the logic, this code is on GitHub. You can go afterward. You can give you the link. It's pretty there, but it's simple code. The point is that when you click, we start the loading of the resource. Okay, then we set timeout the showing of the curtain. When the set timeout fires, you check, is the content already loaded or not? Because if it's loaded, okay, I'm done, I don't need to do anything. If it's not loaded, when this timeout fires, I will show the loading curtain. And in that case, I set another timeout to say, okay, this loading curtain, it has to stay here at least 1 second in order to do not cause the problem that we saw before. Okay, so it's a composition of timeouts that we can solve with jQuery. It's pretty easy with the fired objects, are just the very, very old implementation of modern promises in the JavaScript 2015 or whatever name it used today. Okay, so it's a bit more code, but we can get these two behaviors. We wait a bit. If the content comes fast, we don't show anything. The user will perceive an almost immediate response. So it will be really, really happy bunny. If the content is slow, we'll show the loading curtain with all the animations that we can put in, and the user, hopefully, it will not be totally pissed off. Okay. What's important here is how much we wait. That's a little table that I totally stolen from another presentation with a clever screenshot. So this is basically the timetable of how our brain can stay focused on a simple task like clicking on a link and waiting for a response to come. We have below 100 milliseconds, we don't perceive anything. It's just straight away. 300 milliseconds is our kind of now. It's near to now for us. Okay, that's, by the way, what you have on your phone, that if you apply an on-click in JavaScript on your phone, he will wait 300 milliseconds. That's why web application on a phone, by default, they seems to do not perform like a native. That's not true. Just use touch events and you get native performances. Seriously, don't stick with that.
That's the first thing I do whenever I start coding. It's in the mobile. Why the hell is waiting so long?
That's great. But that's a lot. I've met a lot of people that say, "Oh no, 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 the web will never perform as native because you click and nothing happens for a while." Come on, that's not true. 300 to 1 second, your mind starts to drift away. That's why the zero 0.8 number that I choose, it was just a magic number for me. I chose 0.8 because it's kind of fast enough, but not too much. So your mind starts to drift away with this loading time, but luckily the content in that case will come fast enough to get you back to the point. Okay, but it's still not a perfect user experience. So let's try again. I click 0.8. 0.88 is quite an average, really good performance today. Okay, this is, you have to work with those guys to have this kind of performance. But 0.8 is quite good. 0.8 with this implementation, come on, it sucks. You have the time to notice that nothing is going on. Can we do better than that? Can we? Yes, we can. And it's even simpler. It requires a really tiny bit of more code. What do? We just add another animation. So we combine. Okay, we just have the knowledge that if I animate anything in that page, you will look at it. So we just go crazy with animations. Okay, this one actually comes from animate CSS. It's just a file that I dumped in the page. I didn't write a single line of code for that. Okay, but it just works. The amount of time the animation takes is exactly the amount of time that I'm waiting for the content to come. So no way you will ever perceive this as a waiting time. That's what we can achieve with perceived performances. We just trick the brain in not to be passive while waiting. So you don't wait. I don't want you to wait. We play with the UX part of the equation that we saw in the beginning. We just play with that one. And oh, I show the code here. This is just the same thing. And I am adding a simple add class, remove class animation. So it cannot be more trivial, but it solves the problem. Because with animation, you are not waiting. You are looking at, you are watching the animation. You are consuming the animation actively, your brain at least. After a few times, you may, you may understand that. But okay, that was for the technical part. I have some more demos for how to use perceived performances in forms that I think is incredibly interesting arguments. And I start with just how to use the labels. No more than that, so there's not even JavaScript included. But we'll do that in another talk because I didn't have the time to prepare it. But let's now see how we can exploit this kind of things to make our life at the office easier. So when I say at the office, I mostly say with management. Okay, these kind of weird guys that they don't really play with technology, but they kind of look at us and pretend to point fingers. And so first suggestion that I have for you is be able to demo 24/7. Okay, whatever you're doing, it can be a simple CSS, a web page, a complicated application. You have GitHub. Okay, in GitHub, you push everything online. You can simply clone your repository in 2 folders in your computers. I'm serious about that. You can create 2 clones. In one clone, you keep the master branch or your development branch, whatever. So no active code there. And in the other one, you just hack on it. It's like the dirt state of Git. So one manager comes into the picture and, what are you doing? Because they do like that. Okay, you just stop the process here, start the process here, and you can demo the latest stable version of your project. You don't have even to play with stashes or stuff like that. It's even more simple, 2 folders, and you're able to demo in any possible moment. No way you can say, no, at the moment it doesn't work, come back later. Because if you do that, you just confirm the expectation of the evil manager. The evil manager wants to just point the finger at you, you're not doing your job, you're just not able to demo. No, be always ready to demo to anybody. It's not your manager, seriously, it's anybody, it's even yourself, being able to use your product, as Nale was saying before, in any moment with the latest stable version of it, even your own development stable version, so you can compare it with your active development version. And it's simple, we have the tools to do that. I really wasted a lot of opportunities in my career because I wasn't able to demo in real time. Second advice, create bugs in your software. I know that here some QAs can be a bit pissed, but let's talk about expectation and performances. Okay, somebody, I don't really know who, expect your software to have bugs. Okay. There is this thing that, for every line of code that a developer works, there are enough number of bugs to compose every kind of combination of the characters inside that single row. So it's a lot. So seriously, when we write code as developer, when I write code, I introduce bugs that I don't see. And I do all my best to prevent that, and the QAs help me in doing that. The best I do, the less bugs I produce, real bugs I mean, in my code, the more I work against myself. Because again, the evil manager will expect my work to be good every time. So when I really fuck up, when I really introduce a bug that I'm not aware of it, the manager or my customer that works really better with freelancing relationship, your customer that for a year expected always a perfect code, a perfect product that was always up, and out of the blue you just fuck up, he will point a finger at you and say, oh, you're not good, you just fuck up. Okay, so introducing bugs that you know, that you are really aware of it, is kind of like a vaccine thing. Okay, you can release a bug, you know that there is a bug, you let and even encourage your manager, boss, colleague, QA, or a customer to discover the bug, and you promptly fix it. Okay, because nobody expects you to be perfect, but everybody expects you to be proactive in taking ownership on your fuck-ups. So, fuck up in a simple way, release it, and fix it. And that's the way you will really modify the expectation of your customer, your boss, your colleague, whatever, because they will think that you are an extremely good guy, because you are human, you fuck up a lot, and you fix everything. Okay? That's really important.
I already do that a lot.
Yeah?
Maybe I'm really good, but I already do that a lot.
And yes, saying no, this is kind of personal. I started my career by freelancing, okay, and I come from a really little region in Italy in which we have this saying that is like, shut up and work, okay. So my approach to work is like, if you are my customer and you ask me whatever, it was, yes sir, yes sir, yes sir. And it was just coding it slave mode, okay. It never paid off. It doesn't matter how much I worked, how many hours, how much effort I put in it, it had never paid off. The moment I started to understand how to say no, because it's not just say no in a bad way, it's how to say no, how to motivate, how to evaluate your own job and explain how much time a solution can require also to work it out in a good, high quality way. It will help you a lot in modify again the expectation that your customer has on you. Okay? Yeah, that's everything I got tonight. Thank you.